movie, we speak about endothermic and exothermic reactions. We speak about reaction rate, and we do a calculation about reaction rate, and we also perform a stoichiometric calculation. All that while we answer this question, which you can download from the link below. We see that this question is about a carbonate reacting with an acid. Click that link there to watch a movie in which you can see that reaction, and you will see that the carbonate reacts to produce a soluble product, so therefore the mass of the carbonate decreases over time, which is relevant for question 5.2, and it also produces carbon dioxide gas, which is relevant for 5.3. We're given delta H for this reaction. It is less than 0. In other words, it's negative. And we're asked if that tells us it's an exo or an endothermic reaction. When delta H is negative, that means that the chemical potential energy of the products is less than the reactants, meaning that to change from the reactants to the products required a release, a net release of energy. It's an exothermic reaction. For a more detailed explanation about the changes of energy involved in chemical reactions, click here. 5.2 asks us to calculate reaction rate. For more detailed explanation about what reaction rate is and how to calculate it, click here. And you will see that for that we need to know the change in reactant or product, in this case reactant, per period of time. And indeed we are given that information. One way to calculate reaction rate is the negative of the change in mass of a reactant over the period of time to make that change. And we're given that information for the antacid tablet. Change in mass of the reactant is final mass of the reactant minus initial mass. That's 0.25 grams minus 2 grams. And the period of time that it took to make that change was 30 seconds. We do that on our calculator, we find the answer is 0.06 grams per second. We're told that the antacid tablets are 2 grams in mass, and only 40% of that mass is calcium carbonate. An antacid tablet is placed in hydrochloric acid, and we're asked to find out the volume of carbon dioxide at STP that is produced. The first step is to work out the reaction ratio that's relevant for this particular reaction. We can give this in various forms. Let's start off in the mole form. That is very easy to determine. It's simply given by the coefficients in the balanced equation. Now we're only going to focus on those chemicals for which either information is given or required, which is calcium carbonate and carbon dioxide. From the coefficients, we can see that the mole reacting ratio for those two is 1 mole is to 1 mole. But in this particular question, the information we're given about calcium carbonate is not in moles, but rather in grams. And the information we required about carbon dioxide is in decimeter cubed. So let's give this mole-mole ratio in the gram decimeter cubed format. So 1 mole of calcium carbonate has what mass? We go to the periodic table and we look up the molar mass of calcium carbonate. It's 100 grams. We're told that this occurs at STP. What is the volume in decimeter cubed of 1 mole of any gas? 22.4. So we know that the molar ratio converted to a mass-volume ratio is 100 grams calcium carbonate for every 22.4 decimeter cubed, or rather the other way around, because this is the output, this is the product. 22.4 decimeter cubed of carbon dioxide will be produced for every 100 grams of calcium carbonate that reacts. Now, we don't have 100 grams that reacts. We don't even have 2 grams. We're given 2 grams as the mass of the antacid tablet. But remember that only 40% of that mass is actually calcium carbonate. So the next step is to determine, well, how much calcium carbonate does actually react. And then we'll use that number to determine, by means of this proportion, how much carbon dioxide therefore must have been produced. So firstly, we need to determine what is 40% of 2 grams. And the answer, 0,8 grams. That is the mass of calcium carbonate inside one of these antacid tablets. So now the question becomes, what volume of carbon dioxide will be produced when 0,8 grams of calcium carbonate reacts, and the reaction ratio in which these two react is 100 grams of calcium carbonate for every 22,4 decimeter cubed carbon dioxide. Notice this conversion factor here. 1. Its units are such that they cancel out the given unit and introduce the required unit. 2. The top and bottom refer to equivalent amounts for this particular reaction because they are the reaction ratio in the required units for this particular reaction. And so we are in effect multiplying by 1 because the top and the bottom are equivalent. We do this on our calculator and we find the answer, when we round off, is 0,18 decimeters cubed of carbon dioxide. Don't forget to watch the second part of this question in that movie there. And don't forget either to like and to subscribe.